Hey guys, what's up? Welcome back to the Python Fundamental series on Datatypes. And this third episode I will talk a bit about Booleans. So Booleans are one of the easiest to understand data types. They usually hold two values, and that is either true or false. And it's the easiest way to evaluate something in computer science, since a Boolean value can be represented with just one bit, being false as 0 and true as 1. So it's very neat if you want to do comparisons or represent just general value or truth of a statement or a comparison or whatever. Now, one thing that is important in Python is that the Boolean values are capitalized. So false starts with a capital F, and a true starts with a capital T. Sorry. You will get a Boolean if you have a comparison, a Boolean value that is. So say we wanted to know if 1 is greater than 9, and we print that. And sure enough, 1 is not greater than 9 and returns false. However, if we switch that around to a 1 is less than 9, this returns true, since 1 is less than 9. You can also do, you can compare values, and you denote that with two equal signs. And with that, you kind of ask if 1 is 9, so is 1 9, sort of. And sure enough, 1 is not 9. As you would expect, I guess. So that is very important, that the actual comparison operator is two equal signs, because one equal sign is the assignment operator in computer science. So the way you assign stuff is you have a variable var equals 9. So that doesn't mean that var is equal to 8 in a mathematical sense, but it is rather assigns the value 8 to the variable named var, and that is important to keep that in your mind for Boolean operators. You can also check if something is greater or equal to 9, or if something is less or equal to 9. That is basically the exact same way. Important here is that you start with the less or equal, with the greater or less than, and you afterwards have the equal sign. And we can evaluate all these cases. Now, another interesting thing you can do with Boolean operators is you can evaluate the sort of Boolean value of, for example, a number. And the way you would go about this is you would type bool 9, and if we run this, it returns true. And you can think of this as sort of the Boolean representation if 9 is 9, and this will always return true for any kind of data types. You could do this for string, print that, it's true. Or, I don't know, maybe you could even do a list where you go string 1, and we go string 2. Oh, by the way, I enlarged the text size in my editor, because in my previous recordings I felt that if you guys watch this on a small device, it's rather hard to read the screen. Please let me know if this is sufficient, because I wouldn't go with this kind of magnification. I would prefer this, but let me know in the comment section if this is fine. Anyways, to evaluate this, we would run if this list really is this list, which obviously it is, and it also returns true. So this might seem kind of pointless. This is also what I thought, but it comes in handy if you want to evaluate if something is empty. So if we would pass in an empty list, like this, and we ran that, it will return false. And this is really where this functionality comes in handy, because that way you can easily check if something is empty. It also works for empty strings, so if I pass in an empty string and I ran it, it returns false. However, if I put something into the string, like even a space is enough, I guess, and I run it, sure enough, the string of space is the string of space, and it therefore evaluates as true. But if it's an empty string, it will return false. So it comes in handy for checking if something is empty. This also works for none. So if you go and check if, actually let's do it this way. Let's say A is none. And then let's evaluate the Boolean representation of A. And it's false since A is none. So you can also check if something is none with this bool method. Now in Python there's also a way where you can do Boolean indexing of lists, but this is something I will talk about in my NumPy fundamental series, which I'm going to start recording soon. And this is also where Boolean indexing comes in handy if you want to work with or if you have to work with rather large lists or arrays and you have to perform operations on certain conditions. Now, the last thing Booleans are valuable for is for functions. So sometimes you see something like the function, I don't know, my func, and it's not a class method, so it's just a function, and we have a param1, let's say. And sometimes you just want to check something complicated and evaluate it. So say param1, which is the first parameter we pass into param1 is, say it's the integer 2. Okay. So if we wanted to check a condition, in this case, let's just check what param1, sort of the only parameter we pass into our function is. So say if param1 is equal to 2. Again, this is the Boolean operator. It's not the assignment, so we do not reassign param1 to 2. We want to do a Boolean comparison, as I explained earlier. Then we want to return true, and else we would like to return false. Oops, return false. Now we have to call this function, obviously, since we just defined it. Now A is my func, or let's print it actually. Let's print my func of param1 and run that. And we have a syntax error. Great. Oh, because I forgot the parentheses. And if we run it, it returns true since param1 is 2. Now let's check if it really works. Let's put param1 and assign it to the value 4. And if we rerun it, it returns false. This seems like a nonsensical example because it kind of is. I just wanted to prove how that it works, and it comes in handy for functions. But in a real case scenario, you would not do this trivial check, since you can do this outside of a function, or usually you want to check more complicated stuff, I think. Alright, that's about it for Booleans. I hope you guys enjoyed this video. Please check out the other episodes of my Datatypes fundamental series. And other than that, I hope you guys are having a great day. Hope to see you soon in one of my upcoming videos. Take care. Peace.